Okay, let's see how we can get this stuff going for taping. Just in case you missed class or you didn't quite get something in class, you can replay these things and um, see how you're going to go and get things done. What we started with on day 2 was the fact that we need to learn how to work with the denominators and combining fractions. And you have to have like denominators here. I've got like denominators here, so it's just going to be 2 pi, because that's 1 plus 1 over 2, which is just pi. And that makes sense because, I've got a half, and it adds up to be a whole. Now here in this next one, I got 3 and 2, and they both go into 6, and I'm right here. They both go into 6 as I'm going through, so we got to understand the fact that I have to have 6. And what do I multiply top and bottom to make 6? If I multiply the top and bottom by those values to make 6, I now have 2 pi and 3 pi over 6, and so it's 5 pi over 6. That's my answer. Next one, fourths. So if I multiply the top and bottom by 2 here, I can make 4. And I've got, in this particular one, I got pi over 4 plus 2 pi over 4, and that's going to be 3 pi over 4. Okay, next I've got 6's, so I'm going to multiply by 3, and I've got 3 pi and 4 pi over 6, but that can be reduced to be 2 pi over 3. And my next one, remember, like denominators, got to be 8, so I'm going to multiply this side by 4's, remember, form of 1, okay, so it's 4 pi plus 1 pi, it's 5 pi over 8. Now, next, back to 2 and 3, and a likelihood of 6 being there. So when I'm looking at this problem right here, I've got pi over 2 and pi over 3. So I'm really talking about myself getting out of the pi over 2. So I got pi over 6, or 3 pi over 6. Okay, and I've got 2 pi over 6. Multiplying top and bottom by 2, top and bottom by 3, so I got 5 pi over 6. Here they're both 3's, so it's 2 pi over 3. I got 4 and a 3, that's 12ths. Okay, so I got to multiply by 3, multiply by 3, multiply by 4. So I got 12ths on the bottom, and I got 7 pi over 12. Here I've got 6 and 3, so I've got 6, so multiply by 2, it's 3 pi over 6, but remember I can reduce that, it's pi over 2. Here I've got 8 and 3. 8 and 3, the least common denominator would be 24. So I'm going to multiply the 8 by 3, top and bottom, okay, by 8. So I've got 11 pi over 24. Now, so far we've just been adding them, and now we got to look at a subtraction and adding and combining things. So pay attention to sign up front. And in this next one here, I'm looking at 6 again. So if this is 3 pi over 6, and this is 2 pi over 6, but I get negative pi over 6 is my final answer. Excuse me. This next one, I've got 3 and 4. I got 12, so I've by 3 on the right one, and here I multiply by 4. So I've got 8 pi on top and 3 pi, so I got 11 pi over 12. This, I'm not sure why that did that, but we have negative 3 pi over 4 and 2 pi over 3, and again that's a 12. Multiply by 4, multiply by 3. I got 9 pi and 8 pi, so it's negative pi over 12. And I'm looking at 5 pi over 6 and 3 pi over 8, and that's going to be 24. So this side we can multiply by 4, so I got 20 pi over 24. Plus this side, multiplying by 3, I got 9 pi over 24. So I got 29 pi over 24. Please notice I'm always writing that pi on top with the denominator, with the numerator, not with the denominator. So it's pretty obvious that it is part of the numerator as we go through. And now I got 5 and 8, and they have 40 involved. 8, top and bottom, 5. Top and bottom, so I got negative 5 pi over 40 plus 24 pi over 40. Okay, well that's going to be a 19 pi over 40 when I'm finished. Okay, and if we want to check, we can look at these answers down here and see where everything's going to go. If you have further questions on fractions, please let Bloom know. Okay, let's get on with the rest of today and start talking about this. This was supposed to be an example that you ran. The things you're supposed to find, first of all, you found that the amplitude is 2. Okay, so let's look these over as we go. We'll cut that out and we'll use the right colors. Amplitude's 2. Okay, my B is 1/2. All right, so my amplitude is 2 as I go through. My B is 1/2. Now I can find from that B, I can find the period, and the period is 2 pi over B, which becomes 2 pi over 1/2. But remember, because of fractions, this is the same as multiplying by 2, the division by 1/2. So now it's 4 pi is my period length. Now I got to take that 4 pi and divide it by 4 to find my 5 key points. So 4 pi divided by 4 is going to help me find that my period is each one of my key points in my period are pi apart. Okay, so I'm going to start at 0. I don't have a shift left or right. That's what H would be, is my shift. But I don't have a shift, so now I'm starting at 0, and I'm going pi, 2 pi, 3 pi, and 4 pi. You'll notice that I already broke my graph up that way, and I decided to do that completely and totally from the values that I found here and here. Okay, so I knew my period was going to be a full 4 pi, and I knew that I had to divide it by 4 to find my 5 key points. Remember, all this information that we're giving you is about graphing sine, cosine functions quickly. All right, so now I've got Chala written on the side because I already had it was cosine. And for cosine, we start high, we go to the axis, and my amplitude was 2, so at the axis, instead of 1, it's 2. Then I'm going to go down to the axis, below the axis at 2. I broke this up into half increments, and then back to the axis and back up high. So when I graph this, it's going to go just like this as I go. And I keep doing this pattern. So as I come back here, I come back up here. Keep in mind, cosine starts high, goes the axis, goes low, back to the axis, back high. And I just brought it back so I could fulfill my graph 2 full periods. So keep that in mind as you're looking, the things that we need as we go. Now, our next topic is frequency. The frequency of the sinusoids is directly related to period, and the frequency is reciprocal of period. So whether it's sine or whether it's cosine, okay, whether it's sine or cosine, we're talking about the fact that our frequency is absolute value of b over 2 pi. 2 pi being the wavelength, okay, or period length, and absolute value of b, remember, comes from right here. Okay, this value inside, and we have to have 1 in front of x and able to read this properly. So we have to actually factor the b out when we're working with it. So when we're finding the frequency of sinusoid, and we're going to do this with mode and radians, because I'm going to ask you to graph it so you can see it visually. Why is mode and radians? Because we're working with things in 2 pi with our frequency and length, so we pay attention to that. So here's the deal. When we do this, I've got my period, okay, and remember, frequency, when we're working with frequency, it is just the reciprocal of our period, and period is 2 pi over b. So our b is 2/3, that's where we read that, b is 2/3 right here, okay, as we go through, it's 2 pi times 3 over 2, which is 3 pi. So what this means is my frequency, which is 1 over p, is 1 over 3 pi. And to describe this, this is one wave over 3 pi. And if you graph it on your graphing calculator, and I would strongly recommend to do it so you get a visual what this looks like. Okay. Now, I want you to try one. Okay, you're going to do the same thing. Remember, this frequency, as we go through, is all talking about the fact that we find b. Okay, so we found our b, which is 3. We put it in period, so we have 2 pi over b. Remember, and then we take it and do its reciprocal. So as we're looking at that, our frequency, which is 1 over p, and the frequency is the absolute value of b over 2 pi, is 3 over 2 pi, which means in this case, I am going to have 3 waves, 3 full periods in 2 pi. 3 waves over a 2 pi period. Okay, check it out, what it looks like in graphing calculator. And that's true with sine and cosine. It doesn't matter whether I use sine when I do this or cosine. It doesn't matter about the amplitude. We are just talking about the frequency, and it's the ratio as we go through. Now, we're going to look at getting one sinusoid from another by a phase shift. And this phase shift idea is kind of interesting. If you look, I've got a sine and cosine are complementary functions and are co-functions of each other. They only differ by a phase shift of pi over 2 or 90 degrees. So we're right here. We're talking about this stuff. So they only differ by a phase shift of pi over 2 or 90 degrees. So if I'm down here and I'm checking this out, to get cosine theta, sine shifts left pi over 2. So if I say sine, if I take my sine curve and I shift it left, okay, which is, pi over 2. It's a pi over 2 shift, brings sine to cosine. So if I want to look at that and see what it looks like as a function using our function notation, we are checking out this new change. Look at it, I'm adding pi over 2, which is a shift to the left, pi over 2 units. So as we go through there, shift to the left, pi over 2 units. Now, in a similar manner, I'm going to take my sine theta, cosine shifts right pi over 2. To get to sine theta, cosine is going to shift right. So if I go back up here and cosine shifts right pi over 2, so cosine shifts right pi over 2 to get the sine. Now, keep in mind what that's going to look like as we go. Sine theta is equal to cosine theta minus pi over 2 as we move this on. So that's the connection between sine and cosine and being able to write one in terms of another if we so chose. Now, keep in mind, we can just go and have those adjustments happen as we work through different functions. Now, let's talk about the phase shift h, because I've alluded to it in example 6 there. H is all about the horizontal shift. Okay, and the horizontal shift, just like stuff we've done before, when the horizontal shift, when h is negative, it's going to go to the right. When it's positive, it's going to shift to the left. The phase shift, as we talk about this, I'm going to get a pointer here so you guys can follow along. The phase shift has a horizontal translation of the graph along the x-axis. If positive, it shifts left. If negative, it shifts right. Now, to find the new period and 5 critical points of the graph, the sinusoid, we're going to follow these steps. And we're not going to change it too much, but I want to really emphasize this part. Because what we're going to do is going to have a inequality that we're going to simultaneously solve, a range inequality. And we're going to have 0 is less than whatever's inside the cosine or sine argument. And that's less than 2 pi. Remember, our general period is from 0 to 2 pi, so it's 2 pi big. And we will use this idea to help us find our new starting point, our new ending point, and ideally we'll be able to recognize the length of our period as well. So with this idea, this is what we're going to do. We're going to take this and find our new critical points. I know A is 3, but I'm really here to find out what's going on with my period. So I'm going to go 0, x minus pi over 2. Remember, I've got that x minus pi over 2 here. Okay, and now I simultaneously solve this. So I'm going to add pi over 2 to all 3 sections. And I can't say 3 and write 2, so pi over 2 is going to be added this section. So I add pi over 2 here, that's as x. And I add pi over 2 here. So this is 2 pi plus pi over 2. Well, this is going to be pi over 2 on the left, less than x, less than or equal to, I should say, less than or equal to. This above here becomes 4 pi over 2, and so I've got 5 pi over 2. So what this means, I'm going to start counting at pi over 2, but I'm going to have my increments. And if you're not comfortable with looking at this and seeing that it's going to still be 2 pi because b was 1, we can talk about it here with our period. It's 2 pi divided by the absolute value of b, okay? And as we look at that, I'm grabbing my cursor, 2 pi over 1, remember that's the absolute value of b, is equal to 2 pi. Now this is the whole period. Okay, it is embedded between pi over 2 and 5 pi over 2. This just tells us where I'm starting and where I will end. Now, I'm going to divide this period into 4 equal regions. So I'm going to take and, oh, well, hey, 2 pi divided by 4 is pi over 2. So I'm going to start counting at pi over 2, and then every pi over 2, I'm going to move up. So I have my start at pi over 2, then I'm going to go to pi, which is 2 pi over 2, and then I'm going to go 3 pi over 2, then I got 4 pi over 2, which is just 2 pi, and then I got 5 pi over 2. Okay, so these are my 1, 2, 3, 4, 5 critical points that I'm going to put on my graph and start graphing my sine, and sine starts on the axis, so this will be axis high, axis low, axis as I go through. So that's an example of what we're going to do and how we're going to use this idea to help us start and end a period so we can graph it a little easier. But let's look at this, combining a phase shift with a period change, because we talked about a phase shift, we talked about H, we talked about our B and our phase shift with H. So combining a phase shift with a period change. Construct a sinusoid with a period of pi over 5. Now, that's the whole length of my period. So something's going on there. I've got to check that out as we're going, okay? And then amplitude is 6 that goes through 2, which is going to be our H, and 0. And what I'm doing is I'm looking at a something like this. It could be sine or cosine, but because it's 2, 0, it stays on the axis. I'm going to start with sine. I'm going to help myself out, and I'm going to use sine because it goes through 2, 0, so I'm just going to have it start at 2, 0. Okay, so now let's talk about the other pieces of information I was given. Over here, I'm going to talk about amplitude is 6. I got that right here. And I was told that the period, okay, was pi over 5. Well, I'm going to use the period to help me get my b. And in order to do that, I've got to understand that 2 pi divided by b, and that should be an absolute value of b, absolute value of b is pi over 5. So now what I'm going to do is take this information and I'm going to solve for b. So now if I'm solving for b, I've got 2 pi over the absolute value of b is equal to pi over 5. Now if I divide by or multiply by the absolute value of b, I've got 2 pi equal pi over 5 times the absolute value of b. Now, to get rid of the pi over 5, I can divide by pi over 5 or multiply by its reciprocal, which is 5 over pi. So on both sides, 5 over pi, that's going to knock those guys out. And I've got 10 as a result left over. So 10 is equal to the absolute value of b. Okay, so that's my b value inside. So let's look at the things that I know. And remember, since it's going to start at 2, I'm going to subtract 2 because I'm going to shift the sine curve. I'm going to shift the sine curve 2 units right. So in order to do that, I got to subtract 2 inside. So I'm looking at this, and I've got 6 as my amplitude, sine 10, b, and I'm shifting it 2 units to the right to take care of this. But now, remember, I'm combining a phase shift, and I was supposed to combine a phase shift with a period change, construct a sinusoid with a period of pi over 5 and amplitude 6 that goes through 2, 0. Now, if I wanted to do this as a cosine, and remember, I decided to use sine because sine starts on the axis, and this started on the axis. I tried to make my problem easier. Now, remember how it's connected. Remember, we're talking about remembering how it's connected. I'm going from a sine curve a sine curve to a cosine curve. And to go from a sine curve, to a cosine, I'm going to make it a cosine. Cosine is related to sine. Cosine is related to sine. So everything else is the same except I'm going to slide it pi over 2. I'm going to subtract a pi over 2 when it's in the cosine value, because to get to sine, I've got to slide it to the right. It's a phase shift of pi over 2. So I'm going to go subtract pi over 2 on my cosine curve here. And so everything else is the same. 6 is the same. As I'm looking at, the amplitude's the same. The B's the same. My stuff inside is the same, except I'm going to move it to the right. That's why I'm subtracting pi over 2. And now I can express the same idea that I did in sine as a cosine. And go ahead and graph the two and check out the difference. If you have a colored graph calculator, it works out real nice. Okay, so now it's time for us to put the stuff we've learned today in an example. And you got to keep in mind as we go today through these examples, just be patient with yourself. If you need to rerun the video, see how it goes. First thing we're going to do, we're talk about amplitude. And let me get a little makeshift cursor here so we can talk about amplitude. Amplitude is right there. That's my amplitude, it's 1/2. My B happens to be 1, there's no B in front here. And my H, I've got a negative pi over 2, so I'm going to have a shift to the left, pi over 2. But let's do one thing at a time. I've got 1/2 for A, and I got my B is 1, so my period will just be 2 pi, okay? Because remember, the period is 2 pi divided by the absolute value of B. Now with that, my 5 key values is 2 pi divided by 4, and so I'm going to start counting at 0, I'm going to start counting. My 5 key values here are negative pi over 2 because I have a shift. So I've got a negative pi over 2 shift, and I've got to make sure I get that on my graph. So that's where I'm talking about this information. So a regular graph that would go for cosine, start up here at 1/2, would shift pi over 2. So this is where I'm starting at negative pi over 2 because of my H. So this is a shift left, and if you want, we can even see this like this as we talk about this new idea of phase shifting. So we fit our period that we talk about, and I just subtract pi over 2. So I'm starting at negative pi over 2. I've got x, so I'm subtracting pi over 2 from each side. And my period will end, remember, that's 4 pi over 2 minus pi over 2 is 3 pi over 2. So my period ends at 3 pi over 2. Consequently, that's why I have these two values. And then everything in between, remember, 2 pi divided by 4 is equal to pi over 2. So I count up by pi over 2. Negative pi over 2 to 0, 0 to pi over 2, and then to pi, and then 3 pi over 2. So keep in mind as we're going, there's a reason for this as I go for my critical points. And since it's cosine, I'm going to use Chala. I'm going to start high, and my amplitude's 1/2 as big as it normally is. So normally it's at 1. So normally I'm up here at 1, okay, right across here. Let's go ahead and put that in. Normally I'm at 1, and I've got negative 1 there. But now I'm 1/2 as big, so I'm going to go to 1/2 and I'm starting at negative 1/2, and then I go to the axis. I go low, I go back to the axis, I go high, and then I go back to the axis. And remember, I keep going with this pattern now. Everything has been numbered by pi over 2 apart, so I can easily find my spots based on the pattern. I go to axis, I go low, I go back to axis, and now I'm going to get a different color here to do my graph. I think I'm going to do it in red. And I'm just going to graph my cosine. Yeah, it was a little flat as we go. But generally, that's what it's going to look like as I graph out my cosine based on the information I provided, that was provided from the problem. Okay, we're going to do the same thing in B. Okay, I'm going to find A. And let me grab my little arrow cursor wherever I decided to leave that in the last problem. I'll make a new one. We have my little arrow cursor. Negative 1/2. Ooh, this is kind of different, isn't it? So now what I've got to consider is the fact that I have a flip. Remember, A, amplitude is the absolute value, and then I talk about a flip because I'm talking about a flip because of the fact I've got that negative. So I'm going to flip my graph. So I got to remember that when I do this. And this is all about sign, okay, as I'm going. So I'm going to check this out. And I've got my B is 1 again. And my period should be 2 pi. My period is 2 pi. And so my 5 key values are 2 pi divided by 4, pi over 2 apart. Now, keep in mind, I'm going to find my starting value. Okay, because I have a shift. I believe it's going to be a negative pi over 4, and it's going to go to 7 pi over 4. Let's check out, we'll see what it actually looks like with this shift. Okay, so 0, normal, x plus pi over 4 to 2 pi. Remember, 2 pi is the same as 8 pi over 4. That's same as 2 pi. And the reason I'm doing that, I'm subtracting pi over 4. So I'm going to subtract pi over 4 from both sides. And now I've got negative pi over 4 is less than or equal to x, which is less than 2. Remember, I'm subtracting negative pi over 4, so that's 8 minus 1, which is 7 pi over 4. So now that we have our starting spot, which is negative pi over 4, I'm going to count up. And remember, my key spots, 2 pi over 4, are pi over 2 apart. So now I'm starting at negative pi over 4. And this is the same as 2 pi over 4. So I'm going to add 2 pi over 4 to pi over 4, and I get pi over 4. And I'm going to add 2 pi to that, and I get 3 pi over 4. And I'm going to add 2 pi over 4 to that, and I get 5 pi over 4. And I'm going to add 2 pi over 4 to that, and I get 7 pi over 4. What I'm finding is my 5 critical values, 1, 2, 3, 4, 5, for my starting, ending. Remember, I got a start and an end. My starting value, my ending value kind of tells me, and these are my values in between. Now I go ahead and mix up my graph here. Okay, I'm going to step back. Actually, I had it set up. Let's go fix this real quick. Okay, and apparently I got rid of it. So we got pi over 4 there. And we need these marks here. They're four units apart. Remember, pi over 4 is 2, and if I look at it, if I just got pi over 8, I split the graph up into pi over 8, and this is 2 pi over 4, 2 more pi over 4, 2 more pi over 4. I went off my graph, but that's my cycle that I'm going to be graphing. And since I'm graphing sine, I'm going to be looking at the idea that I'm starting at pi over 4. So let's move our starting spot. This is my graph as I go across. And now I'm looking at, instead of my regular, because if we look at this, I've had a flip as I go. So since I'm going to flip, I'm going to start on the axis, but now I'm going to go down a half. And let's use this as 1 and this is negative 1. I'm going to go down a half, back to the axis, up a half, back to the axis. So I've got this part of my graph like that. Now remember, this is a pattern. Once I get my separation or get my count, I can go back pi over 2. Excuse me, did not go very well when I put that little mark in there. It should be 4 apart, my pi over 2 back. And remember, this is up, and then it's back to the axis, and I can continue graphing that same pattern as we go. So that is our negative 1/2 sine. Remember, it flipped. Okay, started on the axis, went down low, and then came up, axis, high, and then axis. Okay, now, some of these have been going along really great, but I want to point out that sometimes they don't go along so hot. Look at this one. First, I've got to reorganize what's going on inside to find my b. So I'm going to say that y is equal to 4 cosine. Nothing's really changed on the outside, but on the inside, I'm going to factor out a 2. In order to do that, that's minus pi over 6. Okay. And remember, if I just check it, 2 times 2 pi 6, it'll become my minus 3. Remember, I need to find b, but I need to have my shift, and my shift is going to be to the right pi over 6. But we're going to see where it's going to end as well when I put it in here. So I've got 2 times x minus pi over 6 is less than or equal to 2 pi, which is less than or greater than 0. And so I divide by 2, and I get 0 is less than x minus pi over 6. It's less than or equal to pi, dividing by 2. And now I'm going to add pi over 6. So pi over 6 is my shift, as I surmised. And then I'm going to add pi over 6. Remember, it's pi over 6, so now I've got 7 pi over 6. Okay, so I've got a 7 pi over 6. That's where we're going to stop. But let's talk about our key values and what their separation is. I've got my cursor lost, so let's bring that back. I got my a, which is 4. So I should be able to get a is 4. My b we found, okay, my b we found is 2. Therefore, what I'm doing on my period is 2 pi divided by my b is 2, my absolute value, okay, which is pi. Now I'm going to take and divide pi by 4. So for my key values, I got pi divided by 4. Okay, so I'm going to go up pi over 4, but my starting value is pi over 6. Now, I got to get my pi over 4 to equal something that's in 6. So pi over 6, that's the same as 2 pi over 12. Pi over 4 is the same as 3 pi over 12. So this is the same as 3 pi over 12. Okay, that's equivalent. So, and keep in mind, this pi over 6 is like 2 pi over 12. So now I'm going to add pi over 6, 3 pi over 12. So 2 pi over 12, and that's 5 pi over 12. And then I add 3 pi over 12 to 5 pi over 12, it's 8 pi over 12. I am not going to reduce. And I got 11 pi over 12. And I got 14 pi over 12. Now, keep in mind, 14 pi over 12 is the same as 7 pi over 6 if I reduce, but it's easiest to realize that I'm just adding pi over 12s, and I could even start this out as saying that that pi over 6 was 2 pi over 12. Okay, so now if I'm going to break my graph up, I got 2 pi's over 12 as I'm going, or so pi over 6 is 2 pi over 12. And I'm going up by 3 pi over 12. So I've split my axis up into pi over 12 increments. So this is pi over 12 as I'm going up. And why I'm doing it is because remember, I'm shifting to the right. Okay, I'm still on the axis, I don't have a K. All right, I'm doing cosine, and I got an amplitude of 4. So I'm at 1, 2, 3, 4. This is 4. This is 1, 2, 3, 4. This is negative 4. It's positive, my amplitude. So I'm going to start, and remember, I've got to kind of shift these over. So this is my high. This is my axis. This is my low. Back to axis, and 1, 2, 3. Ideally, I got my other pi over 12 out here. Okay, and then remember, high, back to axis, low, back to axis, and I'm high, and I will be getting back to axis like right there. So now let's talk about what this curve is going to look like. As I go through my spots, the hardest part of this is breaking it up into pi over 12s. I suppose this really should come around like that. But once I do that breakdown and find my 5 key values, this is the most important thing. First, finding my starting point, dividing my period into 4 equal parts. That's where I did this. Okay, and then I've got my 5 key values here in red. Once I put them down on my graph, I have to recognize what my amplitude is, whether I flip it or not, and then I'm off to the races to graph it. Okay, my next one, again, it looks pretty darn ugly. It looks like it's going to be another 12er as we go through. And I've got my amplitude is 4. My B, gosh, it's kind of hidden in there. It's going to be 2, but let's show you how I pull that out. 4 sine of 2 times the quantity x minus pi over 3. Remember that 2 didn't disappear, and it's there as I finish. So I'm going to take 0 less than or equal to 2x minus pi over 3 to find my starting and ending point. Okay. Now keep in mind, we're going to 2 pi again, okay? And we're going to solve this. So I'm going to divide by 2, and I got 0 less than or equal to x minus pi over 3 less than or equal to pi. Now I'm going to add pi over 3 to both sides, and I have pi over 3 is less than or equal to x, which is less than or equal to 4 pi over 3. Now, be advised, as we're going through this, I've got a starting and an ending spot, and we knew our p was going to be 2 pi divided by 2, which is just pi. So I'm going to take pi and divide it into 4 equal parts, and that's going to be pi over 4. But it is actually going to be working with 3 pi over 12 because we got pi over 3 is my starting spot. So I'm going to start at pi over 3, which is, 4 pi over 12. Okay, that's pi over 3. That's the same, 4 pi over 12. And I'm going to add 3 pi over 12 to each thing. 7 pi over 12, 10 pi over 12, 13 pi over 12, and 16 pi over 12. Now it doesn't look like this, but remember, if I wanted to reduce these, and I'm going to write them out this way because it'll be much easier for us as we go through. If I wanted to reduce these, 4 pi over 12 is pi over 3, and 16 pi over 12 is 4 pi over 3. So those are my 5 key values, and I'm going to go ahead and pop them on my graph as we go, and I'm going to separate it as 1 square is pi over 12. So if this is pi over 12 here, and then 2 pi, 3 pi, 4 pi over 12, 5, 6, 7 pi over 12, 8, 9, 10 pi over 12. Now keep in mind, 11, 12, 13 pi over 12, I have run out of my graph, but I'm separating it out so I can actually get those pi over 12s on there, because going back, I'm going to go back 3 pi over 12, which is a negative 2 pi over 12, and 1, 2, 3, negative 5 pi over 12. And 1, 2, 3, I've got a negative 8 pi over 12. And 1, 2, 3, negative 11 pi over 12. Just to keep in mind where I'm going. Now remember, I moved my axis to pi over 3, which is 4 pi over 12. Okay, and I don't have a k that's going to move my, this is my starting spot. I shifted it to the right, and we kind of assumed that we'd shift to the right pi over 3, so we've shifted to the right pi over 3. And now that I've shifted to the right pi over 3, I'm now going to start and look at my 4, and I have it shifted here, pi over 3. I'm talking about sine. I start at the axis. Now I've got 1, 2, 3, 4, 1, 2, 3, 4, so this is negative 4, this is positive 4, and I start at the axis, and I'm going to go 7 pi over 3, and I go high, because I'm going sine, and I go back to the axis, and I'm going to go low here, and then it's going to go back to the axis, but it's not going to quite be in my picture. So we got to keep in mind that sometimes it's just because I've laid it out, it's not going to be perfect. But then I go back 3, 1, 2, 3, and I'm going to go down low, and then back 3, 1, 2, 3, and I'm going to go the axis, and 1, 2, 3, and up high, and then back to the axis, and then down low. So my graph should come up. Oops, a little bit too harsh. Let's try that again. Okay, let's cut that part of the thing. I start out here, keeping in mind where I'm going, and I'm there, and coming through there. So that should be my graph. If it were perfect, life would be better, but maybe I can get it a little better. We're going to try it one more time. I'll come from the other side, and that way I can see all my spots. Yeah, it's a better deal. As we work through our sine curve and we get there, okay? So that's the end of day 2, and we'll have a start of day 3. Hopefully this graphing is going well. I know these last 2 were kind of tough and persnickety, but not impossible. Have yourselves a great day.